All right, here we go. Question number 11 from our Precalculus homework number 12 in MyLab Math. They want us to solve the following system of equations using matrices with row operations. If the system has no solution, say that it is inconsistent. And so the first thing we need to do is copy and paste these equations into our scratch work and get started. So now that we have the equations copied over into our scratch work, the first thing we should do is convert this into an augmented matrix. So we're going to start with our bracket. We're going to take our first equation. And we're going to notice that within all three of these equations, we do have three variables. So each column of our matrix is going to have to correspond to a variable. It's nice if they're in alphabetical order going across, but not necessary. What is necessary is that each column represents a specific variable. And remember, the word augmented means separated. The separator corresponds to the equal signs, and we need all of our constants on the other side. So this will be the constant column. And now we're going to write the matrix. So for x in the first equation, we have a coefficient of 1. The y coefficient is -1. Notice we have no z, so we're going to put a 0 for the z, and the constant is 2. And then we do the same thing for the next two equations. 7x, no y, -3z, 28. And then we have no x, 7y, 2z equals 14. And that is the very first thing you need to do, is to write the augmented matrix. Now, before we do any row operations, I would like to mention that as you write the matrix, if you miss even one sign, one little mistake will result in instant death, okay? So please make sure you pay attention to detail. So the next step in the process is to get our matrix into row echelon form, which means we need 1s on the diagonal, and the 3 elements below the diagonal, those all need to become 0. Now, what is the order in which you achieve those objectives? Well, you start with the first column, and you work your way down. So we need our 1, which notice we already have, and then we need a 0 and a 0. So what I notice is the bottom row has the 0 that I would like to have in the middle row, and so I'm going to do a row operation called a row swap. We're simply going to take row 2 and row 3, and we're going to switch them out. And then that will get my 0 where I need it in row 2. So the first row is unaffected, and we always want to copy and paste the stuff that doesn't change first. And then row 3 becomes row 2, and row 2 becomes row 3. And that completes the row swap. The next thing that I need to do is I need to get this 7 to become a 0. And the way we're going to do that is with a row operation called row multiplication with addition. In other words, we want to replace row 3 with a new and improved row 3 where we have a 0 instead of a 7. So how are we going to achieve that objective? Well, we're going to multiply row 1 by -7 and add it to row 3. Okay, so check this out. If I multiply 1 by -7, that'll give me a -7. And then if I add to the corresponding element in row 3, -7 plus 7 would give me a 0. And that is what I need. And so this will produce a new row 3. So notice only row 3 is going to change. Row 1 and 2 stay the same. All right, so here I have copy and pasted rows 1 and 2 into my new matrix. And now it's time to execute the row operation. We're going to start with negative 7 times 1 plus the corresponding element in row 3, which will give me negative 7 plus 7, which is 0. And then we need to rinse and repeat. Next, negative 7 times negative 1 is 7. 7 plus 0 is 7. Again, negative 7 times 0 is 0. 0 added to negative 3 is negative 3. One more time, negative 7 times 2 is negative 14. Added to 28 gives us positive 14. And then that completes that row operation. The next objective, if we look at where we're at, trying to get to row echelon form, the next thing I need to do is I need to get this 7 to become a 1. And the way we're going to do that is through row multiplication. Now, think about this. I want this 7 to become a 1. The way we could do that is by multiplying by the reciprocal. The reciprocal of 7 is 1/7. We want to multiply row 2 through by 1/7 and produce a new row 2. So only row 2 is going to change this time. Rows 1 and 3 we can copy and paste. Okay, so I have copy and pasted rows 1 and 3. Now it's time to execute the row operation. Starting with the first element in row 2, 0 times anything is 0, so I don't lose my 0, that's important. And then 7 times 1/7 is 1. I designed it that way. Next, 2 times 1/7. Uh-oh, this is where things are going to get effed up. I'm sorry, I can't help it. 2 times 1/7 is 2/7. But then 14 times 1/7 is going to be nice. That's an integer 2. And that completes the row operation. And now we need to take an inventory of where we're at. Trying to get to row echelon form. The next element we need to change is 7. Needs to become 0. Now, to achieve our next objective, which we said is turning the 7 into a 0, the way we're going to achieve that is through row multiplication with addition. And remember I said once you get your first column the way it should be, you no longer use row 1, you switch to using row 2. So we're going to multiply row 2 by negative 7 and add that to row 3 to produce a new row 3. Okay, so let me explain why this is going to work. If I multiply row 2, if I multiply 1 by negative 7, and then add to the corresponding element below it, that will get a 0. And notice that row 3 is the only row that's going to change, so we can start by copy and pasting row 1 and 2 into our new matrix. And once that's done, it's time to execute the row operation. Here we go. Every element in row 2, starting with 0, 0 times negative 7 is 0, 0 added to 0. Notice I don't lose my 0 there. So that is important. Next, negative 7 times 1 is negative 7. Added to 7 is 0. Remember, I designed it to do that. Next, negative 7 times 2/7. I'm going to bring that over to the side. Negative 7 times 2/7. Hey, those 7s are going to cancel, leaving me negative 2, which I then have to add to negative 3, giving me negative 5. That wasn't too bad. And then last but not least, we need to do negative 7 times 2, which is negative 14, added to 14. Uh-oh, that gives me a 0 there. And that completes the row operation. And now we need to look and see where we're at on our journey to row echelon form. We can see that all of the numbers below the diagonal are 0. Almost all the numbers on the diagonal are 1. The last thing I need to do is to convert -5 into a 1. And we're going to do that through row multiplication. Okay, so here's what we've come up with. Remember, in order to convert an element to 1, we need to multiply by the reciprocal. The reciprocal of -5 is -1/5, and we're going to multiply through every element in row 3 to produce a new row 3, which means that row 3 is the only row that's going to change. So the first thing we can do is copy and paste the stuff that doesn't change. So row 1 and 2 are going to stay the same. And then to execute the row operation, 0 times anything is 0, so I don't lose my 2 zeros. Anything times its reciprocal is 1, so that's going to give me a 1. And again, last but not least, 0 times anything is 0. And now, I don't know if you see this or not, but we have reached row echelon form. And now we can use back substitution to find the solution. All right, so running through back substitution, that says we're going to start at the bottom. We're going to convert that row into an equation, and that should give us the solution for z. Remember that each one of these columns represents a different variable. And so if we convert the last row into an equation, we're going to have no x, no y, 1z equal to 0. And so that is the solution for z. And then if I go back up a step and convert this row back into an equation, I can solve for y. So converting the middle row, we're going to have no x, we're going to have 1y plus 2/7 z. But notice I already know what z is, so I'm going to replace z on the fly with what it's equal to, and then don't forget equal to from that middle row. And 0 times anything is 0. So that's going to eliminate and tell me that y is 2. If I go back to the top row and convert that into an equation, I can now solve for x. So that's going to be x, 1x, minus 1 times y. Minus 1 times, but I know y is 2. No z equals 2. That's what that looks like. And then I can solve for x. -1 times 2 is -2. On the other side would become plus 2. And now I can see that x is 4. And now that I know x, y, and z, I can write the solution as an ordered triple. The solution would be x, comma, y, comma, z. It does have to be in alphabetical order, or at least it does have to be in the order that your variables appeared in your equations. And now we need to go back to our MyLab math and see how we did. And back to the MyLab math, we know that there was a solution, right? We had an ordered triple solution, so we're going to select option A, and then we're going to input the numbers that we got for a solution. 4, 2, and 0. I think there's an inside joke there if you get that, 420. And then check, and we're done. Man, there's a lot to that problem. So please make sure if you have any questions or comments about anything covered in the video that you leave those in the comment section below, or you can text me. And thanks for watching.